Yes, Happy New Year, everyone, and good evening. Welcome to my class. Yes, this is lecture number 5 of Maths Optional for UPSC CSE. Okay, and if you haven't watched the previous 4 classes, then go at the description of this video. You will find a link there. Click over that link and start watching from lecture number 2. From lecture number 2, start watching, because in lecture 1 I didn't teach anything. It was a kind of notification only. So start from lecture 2 and then watch this video. Then you will be benefited out of it. Otherwise, you won't be benefited at all. Okay. So property number 3, we are moving on towards the property number 3 in continuation of the class day before yesterday. If A is an orthogonal matrix, okay, if A is an orthogonal matrix, if A is an orthogonal matrix, then A inverse is also an orthogonal matrix. Okay, if A is an orthogonal matrix, then A inverse is also an orthogonal matrix. So we have to prove it. So proof is over here. Okay, as A is an, it is given to us as A is an orthogonal matrix, as A is an orthogonal matrix. So by definition of orthogonal matrices, we have something of this kind: A transpose is equal to I is equal to A transpose A. Okay, then what we will do, taking inverses, taking inverses about the equality sign. Okay, we are taking inverses on all the 3 sides. Okay, so after we take the inverses, we get something of this kind: A transpose inverse, okay, is equal to I inverse. Now the inverse of an identity element, is an identity element itself. Okay, so A transpose A inverse. Okay, now this very well, that inverse of an identity element is identity element itself. So what will this be? A transpose A transpose inverse is equal to I is equal to A transpose A inverse. Okay, so this is the thing. Then what will happen? You know this very well now. Now we know this very well, that AB inverse is equal to B inverse A inverse. Okay, you know this very well, right? So applying this property, what we will get? On this we will apply the same property. So after we apply that property on this, what we will get? A transpose inverse A inverse, okay, is equal to I is equal to A inverse A transpose inverse. Okay, we got this. Now there is one more property, that A transpose inverse is equal to if you haven't watched the previous classes now, then you won't understand anything. Okay, so I am not responsible for it. If you are new to this lecture and you haven't watched the previous any of the previous lectures, then you must watch them first. Only then you can understand this, because this lecture series is in continuation. Okay, so a transpose inverse is equal to a inverse transpose. This is the property. So what will happen is that these two things will turn out. Okay, this thing, and this thing will be, the transpose sign will come here, inverse sign will go here. The transpose sign will come here, the inverse sign will go here. Okay, like that. So what will happen? A inverse transpose. Okay, let me take the pen. A inverse transpose, A inverse is equal to I is equal to A inverse, A inverse transpose. Okay. Now the meaning of this is clearly, you by the definition of orthogonal matrices. By the definition of orthogonal matrices, we have A inverse is an orthogonal matrix. Okay. Now the fourth property. The fourth property is like this: if A and B are two orthogonal matrices, if A and B are two orthogonal matrices, then AB and BA are also orthogonal matrix. Okay. So proof of this, we will have the proof of this over here. Since, okay, you no need to write since you have put the three dots like this. The meaning of these three dots like this is since. Okay, so since A and B are orthogonal, okay, matrices, so what will happen? Therefore A transpose is equal to I is equal to A transpose A. Okay, this is equation number 1. And similarly, by applying the same definition on the B matrix, we have this thing. Okay, this is your equation number 2. So we have to show that AB is orthogonal matrix, and if AB is shown to be orthogonal, if AB is shown to be orthogonal, then by applying the same method, BA can also be shown to be orthogonal. So we will prove for AB, and for BA you can do yourself. Okay, it is very easy. On the exactly similar lines, BA will be proved. The way AB is proved, the same way BA will be proved. Okay, so there is no difference between the two. Between proving AB or between proving BA, there is no difference at all. Both are exactly the same way. So right over here we have to show that AB is orthogonal matrix based on the above two equations. Which two equations? These two equations. Based on these two equations we have to show that AB is orthogonal. Okay, so what will happen? So that means we have to show that. So what we have to show, in order to show that AB is orthogonal, in order to show that AB is orthogonal, we have to show that AB AB transpose is equal to I is equal to AB transpose AB, right? So in order to prove that AB is orthogonal matrix based on the above two equations on the previous page, the two equations on the previous page, we have to show this thing. Okay, in short, if we prove this, then we can clearly say that AB is orthogonal, right? Similarly, BA will also show the similar trend. BA will be proved in a similar manner, but no need to prove that. Okay, because based on AB, we can say that similarly we can prove for BA. So let's start with this thing, the one on the left hand side. Consider this. Okay, we will now consider this and make necessary simplifications to reach to our result. Okay, consider consider AB AB transpose. Okay, AB transpose is equal to AB will be as it is, and this AB transpose can be written as B transpose A transpose. Just told you just now. Okay, then what will happen? AB AB transpose is equal to, so we will just rearrange the terms, bring these two terms near. Okay, bring these two terms near to one another. So we will bring those two terms near to one another. Okay, and A transpose will remain as it is. So this B transpose is basically your I. Okay, this is your I, right? Why? Because B transpose is equal to your I. Okay, so that's why. So this has come out to be A transpose. Okay, as AI equal to A by the definition of identity matrix. Now again, by this same property, this same property, this comes out to be equal to I, right? So that implies what? AB AB transpose is equal to I. Okay. Now we have to prove in a similar fashion. You can prove this also. Okay. Similarly, AB transpose AB is equal to I in a similar fashion, just like this. Okay, in a similar fashion. So in examination you have to prove this. Okay, in examination you cannot write similarly and skip the question. Okay, you will have to do it in the examination. Okay, so that implies, in a similar fashion we have shown, right? So that implies that AB transpose is equal to I is equal to AB transpose AB. Okay, so what does this imply? This implies that AB is an orthogonal matrix. AB is an orthogonal matrix. Okay, similarly we can prove that BA is an orthogonal matrix. Okay, so in examination you have to prove it. You cannot write that similarly we can prove like this or similarly we can prove like that. You cannot write that. In examination you have to in reality prove everything. Okay, now fifth property,